Assalamualaikum.
Ateeb, excuse me, just a minute, guys. Like if you have got any question, I have muted everyone. So yeah, for the sake of the event and the decorum of the event, you can just drop your question in the chat box, and me and Ateeb will surely answer you. Right? If you have got any question, you can just drop your question in the chat box. Thank you, Ateeb. You may please carry on now. Thank you.
Hello guys, Assalamualaikum. I hope you are doing fine. And today we'll start our event with a lesser known part of our field in software and computer science, which is known as software quality assurance. So my name is Ateeb Adil, and I'm a student of final year in software engineering department at Mute Jamshoro. I'm a Microsoft Learn Student Ambassador at Student Ambassadors Club New Jamshoro and ex-General Secretary to IEEECS New Jamshoro. There's a lot more about me than just that, but that is not our scope of today. We shall begin with software quality assurance and the world of QA. For today's session, I have broken down the entire session in three parts. Uh, the first part we'll try to cover the introduction to FQA or QA, and in the second part we'll be digging into the actual work and the department and the responsibilities and all of that things, which include test planning, test cases, bug reports, and all of that. In the later session and the third part, we'll try to get hands-on with Azure DevOps. I may put a disclaimer over there. Instead of going through how Azure DevOps works, we'll try to get started working with it. We'll try to just get a surface call from how Azure DevOps works and what features are there. We'll just seeing and the functionalities and the features of the Azure DevOps. So let's get an idea of the field first. QA is a very different field from development. When we think about our scope engineering, we usually think ourselves as of developers. We are always taught that development is the one thing to go. But let me tell you that there's a lot more to software and computer science engineering than just development. There are a lot of people who are not that really good with development or understanding the coding or the programming part usually go for other fields, and one of those fields is SQL. Although engineers in QA and SQA aren't paid as much as developers, but let me tell you that it is the highly second paid job in this world of software and programming and coding. So let's see first what is quality. Here's a random quote from my side. A good quality results in a product that builds correctly and works reliably. We all have went to shopping with our moms, and usually when we go to some cloth market, we usually like some stuff, and we tell our mom to buy that, but she tells us that it's not of that quality. And now what she means by that is the product that the cloth doesn't fulfill the requirement or the mindset or anything that she has thought of buying for us. So just by keeping that in mind, we'll move on to our next slide, which is actually what is quality assurance. A process used to determine whether a product meets specification. This is the most atomic definition that I could find of quality assurance. We go through a process using tools, different methods, different methodologies and processes to determine whether the product that we are building fulfills the user requirement the clients need. Quality assurance focuses on more on improving the software development process and making it efficient and effective as per the quality standards defined for the software product. This is just a further stretch from the basic definition that we go through processes, making and trying to make our product as efficient and as effective by staying and putting our cost low, meanwhile fulfilling the quality standard that we have set for that product. First, let's see that what impact does a QA make in any development team or in any cooperation that it's a part of. First of all, ensuring that the team is building the right product. It's our responsibility as a QA to ensure that the team is building the right product. From a developer's point of view, some requirements can be very different from the actual requirement that the client has put forward or the actual requirement that the user is thinking of. Developers things and see things differently. It's very possible that what they are contemplating of what the requirements and the needs of the product is very different from the client. Helping teams to move quickly with confidence. If the team knows that the product that they are building is correct and the processes that they are doing is correct, they are fulfilling the requirements the client's needs, the client is happy, they can move on with development and all of those cycles with confidence because they know that all of their hard work will not go into vain. Establish and maintain standards. This is one of the most important and our basic job to maintain the standards, to maintain the quality, to see if everything's working properly, reliably, and and not only at this point of time that they are checking with it, also when the product is delivered to the client and throughout its life and maintenance. So SQA or a quality assurance engineer uh, works in teams to produce a quality product basically. We have set clear specifications. We see if the code is implemented as right. We test the code and we release. These four pointers will further break it down and clarify you in further slides down the line that I have planned. First, let's see what is a role. What is the role of a QA in an organization and how he fulfills it. The role of a and before moving on with that, we need to see what role QA requires, like what knowledge that the person needs to have to fulfill his or her role. First of all, we have technical aptitude, business knowledge, DevOps principles, and process and release expertise. You may see here that, as I told you before, it doesn't mention anything about development because we are not coding here. We are checking the people who are actually doing the coding. So they can do all the hard work, but we need to see everything else to maintain the standard and the quality of the product that we are producing. And for that, we need technical aptitude. That means that we need to be expert with our technical skills, our knowledge, and everything else that concerns our very specific department of quality control, of testing, and everything else. The testing could be of many kinds, manual or automation, as we'll discuss further down the line. But the technical aptitude and expertise in that specific department is very required. Business knowledge uh, may concern feature scoping, test planning, test case management, and bug management. What is test planning, test case management, and bug management is planned uh, in the later half of the slides and the session. But what is actually feature scoping? Feature scoping is concerned when you sit down with the client, when you sit down with your business team, your architecture team, and you try to get a grasp of what the client actually wants, what he or she wants is actually doable, it's practical, it's realistic, or just an arrow in some dark room. You need to know what the requirements are. You need to do the documentations and actually know what the client is requiring and what the and how to meet those requirements. DevOps is basically uh, DevOps is a field of its own, but you need to have some knowledge about it that how DevOps is executed. Usually in any software company, the team is broken down into two parts. The first team does all the development and that side of work which is required with the coding and things. Second team is responsible to make that process of coding, releasing, managing, and configuring all of that stuff together, and to set up an environment that is productive, efficient, and effective for the client, for the product. So, as in DevOps, you need to have the knowledge of the tools, the automation processes, and to set up an environment which is productive, efficient, and effective for the product and the client. Will not go much deep into DevOps, but the basic thing that you need to know about it that the knowledge of the tools is very important. You are basically automating the process of integration, of development, and all of that thing. Process and release expertise. Define and implement test procedure and optimize processes. Here, when all the development work is done and all the codes come in, this is basically the last step of a development life cycle when you are about to deploy the product. We'll get into software development life cycle later on, but the expertise in that department is really required by a SQA because this is what you are going to show the world. This is what the end user is getting. And if that end user is not satisfied with it or the product is bugged and of poor quality, then basically all of your work is vain. Okay, now we are here getting into how software development lifecycle and quality assurance come together. Software development lifecycle, for those of you who don't know, the process that produces software with highest quality or aims to produces a software of highest quality in lowest cost in shortest amount of time possible. SDLC is a well-structured of phases that helps an organization to produce high-quality software which is well-tested and ready for deployment or production. It is basically a life cycle, a loop of phases which you run by through every iteration of the development cycle. When you're when you need to when you need the requirements, when you need to define the architecture, when you're coding, when you're developing, when you're testing it, and finally when you're deploying it. So let's just get a look into it. It consists of six basic phases: plan, define, design, build, test, and deploy. In a plan phase, you basically get to know what are the basic requirements. You get set up meetings with the client. You see their requirements. You set up goals. You set up milestones. In definition phase, you basically further structure those requirements and try to develop a process that how you are going to solve those problems and implement those requirements. In the design phase, you go on and try to build functions out of those requirements. You broke break basic goals into milestones and try to find processes and ways how you will be implementing those. Basically, you are designing now the entire software, the entire architecture piece by piece, just like Legos. In the build phase, you actually do all the coding stuff, not us. The coders do that for us. In the fifth phase, we just test what those people have came out with, and if that things need a little tuning or what the problems have might have occurred in the way. And then the sixth phase, you basically deploy the software to the client or deliver the software. Now let's see what how can a QA fit all in all of these six phases. You might have thought that okay, my work would only come in the fifth phase and I do not have anything else between that. But it's actually a pretty hard work to be a QA. You need to be involved in every step from as beginning as possible till the last step. In the plan phase, you look for risk early on. As I told you before, you need to see that whatever the client is saying is actually possible or not. It is whether in scope or not. In the define phase, you get starting with the testing strategy. When you structure all of those functional requirements, all those non-functional requirements and everything, you start to see a pattern that what I test strategy I need to come up with to meet these requirements in highest quality and highest standard possible. In the design and build phase, well, you might see here that it is written test driven development. Well, test driven development is life cycle in its own. Basically, what you need to know right now at this point in this introductory lecture is that test driven development means that instead of writing test cases or trying to develop a strategy after when the code is implemented, you do it before, which means when you are actually doing the code, you are not doing it to fulfill the requirements, but you are doing it to fulfill the test scenarios that has been pre-built according to the requirement. It saves time, it saves cost, and it makes it a much easier and refined job for the developers. In testing phase, you basically complete the acceptance criteria. The acceptance criteria is basically that what quality or what part of software, how much your testing or the product is acceptable to which degree. Some clients may want a product that is just functioning and they could go by a certain degree of deviation from the requirement, but certain high risk or products that are very important, like for example, a banking system, the acceptance criteria could be really high, considering all of those security risks and functional requirements and everything else which is concerned with that company or that specific product. In deployment phase, you basically go through validation and customer support. In validation, you see that whatever the product has been built, it's built correctly, and customer support means that if you have missed out on anything else, it's your responsibility now, and you now need to fulfill that. Or if there anything that you have left out on purpose, now that's your responsibility to fulfill right now. Okay, so now we are going into like the main stuff, the practical stuff, not the practical stuff. Now we'll be covering the theory point right now, but we are going through the actual work, the actual job that you need to do in a company, like the actual desk 9 to 5 job. First of all, we need to see what is a test case. A test case is a set of actions that execute to verify a particular feature or functionality of your software application. A test case contains steps, test data, preconditions, postconditions developed specific for a test scenario to verify any requirement. So basically, what you do in a test phase is basically that you take a singular atomic functionality and you try to write a test case around it so you can get to the main output for your every input. So you will be putting in a input and you try to get the specific output from it. Let's take an example from a login screen. Your inputs will be username and your password, and your output would be a successful login into your profile. But there are many things that could go wrong in it. The person could write invalid username. It, uh, the username could be case sensitive, and the person who's writing it, the username has forgotten his caps lock on. The password could be wrong. There are a lot of things that could go wrong, but it's your responsibility that you maintain the credibility or the requirement. The person should not and cannot log in with a false username or a deviated password. For that, you write a test case. Now, how you write a test case is basically following different steps. And we see that just in a bit. So, basically, what you go through is a precondition and post-condition steps for that specific scenario. When you're writing a test case, you need it to be accurate, economical, traceable, and reusable. So what accurate means that it fulfills its exact purpose. As I told you before that the test case is built around the functionality. The functionality is not built around the test case. So you need to write a test case that fulfills the use of that specific functionality and that functionality only. If I'm writing a use case for maybe a login screen, I won't be covering up the sign up portion. If I'm writing for a test case for a like button, I won't be covering anything of the comment section or the share screen. What economical means is that it doesn't need it, it is unnecessary to put extra steps or extra words. You need it to be as concise or as short as possible. The shortest way to getting to the login screen. And this is what we meant here by a precondition. In this case, those steps could be basically clicking a login button. A precondition would be that you need to be having a valid ID that is pre-set into the database. Traceable means that you're capable of being traced to the requirements. That that basically means that requirements would be that basic sign up that you do before the login part. So which means that before you log in, you need to have a sign up ID. That ID needs to be fixed into that database that then checks with the login. And that is traceable. That means that the server or the programmer or the program should know that this is the ID that I'm getting. In repeatable, that means that the test case should have economical steps as we discussed before, accurate and traceable. That means I could run the same test case for the same functionality over and over again. If the developer has did any mess in the login in the first try, I shouldn't be writing that test case again and again for every development iteration that the developers goes through. That test case should be fixed for that functionality and it should be reusable if necessary. Here's an example of a test case. We discussed how a test case will be of a login. So here's a test scenario. The test scenario is basically what is our requirement, checking customer login with valid data. So this is a one single function of a login that just needs to check with the login with the valid data and the invalid data. Here are the steps that we discussed prior. Go to the site. Here's the site link. Enter user ID, enter password, and click submit. Now you can see that this part of it is not variable, it's not changeable. We can go through these steps again and again and end up on the same login ID. With a valid data, we would always go through the login and actually log into our uh, website or our profile. Here's the test data that we have predetermined, and which is a username which is valid and a valid password. The expected results is obviously the users should log in into the application. As we run the test manually or through automation, we'll discuss the test types later on, but as expected results are with a valid ID and a valid username, we should log in. And as we put into in those ID and password, we would pass the case. In a second case, for the same functional requirement, if we go to the login with an invalid data, the user should not log in into the application. That are expected results. This time we have by our side put in the username and the password which are false on purpose. And as expected, if the developers have implemented and gone through the requirements correctly, the result would be a pass. Okay, now we have discussed how we are writing the test cases. Now let's see what are the types of testing, because there are more than one and we are going to cover some basic test requirements. First of all, there are basically methodology of three basic testing types: the black box testing, the gray box testing, and white box testing. What black box testing basically means is you can take an example of a black opaque box. You cannot see through or into the box. You can only see what is outside the box, and that is what black box testing means. You'll only be testing what you can see. You are not going to dive into the code, into the requirement, the system requirements, or anything else. You will be just testing things on the surface. Just like our prior example of the login screen, we didn't dive into how the server is working or responding. If even the server is checking with the database, how the code is running by, we didn't see any of the stuff. We just inputted our credentials and see if it logged in. That that is what the black box testing means. It's just the basic type of a testing. Gray box testing is much more complicated or technical, if you may. Here we could take an example of a box which is translucent. We could see into the box but not through the box completely. So in the same example as the login screen, we would like to test how the server is responding to the request of a login. So when we input our credentials, we would be also checking that even if the server is actually responding to the request, or or it is just a piece of code or the bug that is making our login possible automatically. In the white box testing scenario, the box is actually transparent. You could see through the box. So the QA person would be diving deeper and directly into the code to see that if the product is valid, see if the developer has done his job properly. Uh, Taking the login example again, we'll be seeing that if we are putting in the valid credentials, does the server respond correctly? Does, does it actually connects with our database and looks for that specific ID and the password? And we'll be seeing that how our every code is responding to our request. Maybe there could be a bug that is not making the connection to the database possible, or anything else. We'll be discussing the bugs and other defects in great detail later on. Right now, we'll be moving with our slide. Okay. So here are the types of testing. There are many more kinds of testing. We could be diving deeper into them, but here are just a few of them: manual testing, automation testing, integration testing, and performance testing. Manual testing is a type of software testing in which test cases are executed manually by a tester without using any automated tools. The purpose, the basic purpose of manual testing is to identify bugs manually in a software application. So as we saw the test case for the login screen, so basically what you will be doing, the tester would be doing, he'll be sitting on his laptop and he'll be manually inputting all of the data and going through by the data in the test cases iteration by iteration. So we'll first be putting all the credentials which are valid, checking if it logins, and then going back to check with the invalid credentials to see if it's logging in. Then he'll be going back with some credentials which are not invalid but have some deviation. For example, they are using some uppercase letters into it to see that the validation for the uppercase has been put it in by the developer. That is basically manual testing. Just sitting on your laptop and putting all the data manually into it and seeing how the application responds to it and if there are any bugs. Automation testing is, on the other hand, we use special automated testing tools. There are a lot of tools which are for automation testing. There's Selenium, there's JMeter, there, there's Postman. Uh, there are many frameworks that enables us to use automation testing. Basically, what you do in automation testing is basically what you did in manual testing, inputting in data after data, deviating the data, putting invalid data, but just you will be making scripts for it. So here comes to a turning point into a conversation where we started it with that you don't need to have great programming knowledge regarding regarding anything to start up as a QA. Well, that is true. You could very off start as a QA engineer with minimum or no programming language. Just grip on your technical abilities, your skills, and all. But that career would be really short-lived and very restrictive because in the long run, automation testing is the way ahead in the QA. You need to automate it, need to have some skills or great skills in automation testing to survive as a QA in a long run, or just you're basically going to get replaced. And I'll just add one more thing that the QAs does the automation testing or automation testing, or they are basically known as the basically when a hiring for a QA runs by, you have basically seen you'll basically see two requirements. Either you see a manual testing expert or you'll see an automation testing expert. The people who are having knowledge in automation testing are highly paid and they are much more paid than a manual tester. So basically what you are doing in automation testing is you are writing scripts, pieces of programs, very easy pieces of programs, just basing loops and basic true false statements that be checking those results, that if that statement or if that data that you have inputted satisfy the test case or not. So it's just the manual testing, but you'll be just going by through it by writing scripts. So that's why we discussed why the test cases should be atomic and should be reusable, because you won't be writing scripts for every other test case, or when the developer has fixed something, you'll again be writing the same script again, but with some variation. You need to write test cases that are reusable over and over again. So as a bug occurs and you send that bug to the developer to fix and he fixes it, but now your test case has failed because you didn't make it reusable. So you'll be again running by it, again doing all of that hard work just to fix that problem. And in the long run, that could be really tiring and problem solving. That basically means that your test cases are not efficient or effective. Performance testing. Testing basically means that the application is speedy, response uh, the response times are good, it's stable, it's reliable, scalable, and the usage of so the resource usage of the software application under a particular workload is okay. So basically, what here we mean that none of us like applications that are slow. We think they hang. We don't like applications that lag behind, and we want to see applications which are responsive. We don't want applications which are not stable, which crashes often, or have reliability issues after some software updates in your phone. Many times we see whenever we are getting a OS update and operating system updates, many or of our App Store or our Play Store applications are requiring some update just to get compatible with that new version, so they don't crash or the reliability of them are maintained. Many applications are very resource heavy. For example, our very own Chrome browser, we all know it's very heavily dependent on the RAM, which could actually slow down the entire process, entire workload. Performance testing is basically there to eliminate any bottlenecks in performance. All of the problems that I highlighted prior, we need to fix them or at least identify them, so we can build our requirements and our functionality and our efficiency upon those requirements. We see that, okay, we cannot fix this thing to work under less operating power or processing power, so we'll fix the requirement to a much higher level of resource resources. Bug reporting. Yeah, bugs. So first we need to clear out something. Not everything is a bug. There are different errors, like exceptions, failures, defects. There is much more. Not everything is a bug. Basically, a bug is a faulty code which could result in incorrect results on crashes. Sometimes we are trying to open a camera app and it just doesn't respond very well, or just crashes, doesn't save the pictures that we have clicked. So it's basically a faulty code that's somewhere in some class producing all of those results. Defects, on the other hand, is a deviation or variation from user requirements when we are not actually meeting the user requirement. The requirement was something else, the product is doing something else. Error is basically a mistake on the developer's point. It could be anything. It could be a syntax error. Uh, it could be some kind of error that they have left in a class or anything else. But it's a mistake on the developer's part. So the now the code is not working because they have failed at the jobs. Exception is a unexpected flow of programmer code when the program actually doesn't know what to do with it. For example, if we are dividing 1 by 0, the program doesn't know what to do with it. It's actually impossible. So, but we have not defined that impossibility. So now the program itself doesn't know what to do with it. A failure is basically the inability of a software system or component to perform its requirement. In deviation, we discussed that we are not meeting the user requirement. In failure, that user requirement is not being fulfilled from a 0 to 100. It's just not being fulfilled. So that results in a failure. Uh, it could be the cause of a failure could be anything. It could be some performance bottleneck that the application is not working, or it could be error at the back or the bug that is actually failing it. But when you are not meeting the requirements, you are actually failing them. So how we fix all this? We fix all this through defect management. It's basically a systematic process in which we identify bugs. Well, I just told you not everything is a bug, but as testers or quality engineers, we see everything as a bug or report everything as an issue or a bug. A defect management cycle contains following steps. We'll not be getting detail detail on these steps, but it just means discovery of that the categorization, fixing the defect by the developer, verifying it by the tester, defect closure, and report at the end of the project. So basically, how you will be discovering the defect is basically by the testing. It could be the tester or even the developer at early ages who could have identified those defects. Then you need to categorize those defects. Well, in a software firm, there are strict deadlines, and the time is a very important resource. So you need to categorize that defect or that bug or that problem, that if it's even worth putting extra time on, because every defect or the bugs, now you need to fix that problem, and need to it is now requiring the double amount of the time. Well, if I'm spending 2 minutes writing a certain code, and well, that code has failed now, so I need to be again writing that code, and it's again requiring me 2 minutes or like 2 hours. So I have just on the same functionality, I'm spending double amount of time fixing it. So you need to categorize it by how important that is. We'll be discussing that importance in the next few slides. Well, fixing the defects by the developers. Well, then when you have categorized and prioritized that how important that bug or the defect is to fix, you will be handing it to the developers, the coders or the programmers to fix that. Once they have fixed that, they'll report it back to you now that this thing has been fixed now, and then you'll verify it or validate it that if that is the case. Once that is done, you'll put that defect to a closure that yes, that problem of that issue has been sorted out, and in the last, you'll just put it into the report that this thing happened or that thing happened for so reason now that has been fixed. It's important to document and report all of this because certain bugs can again come out of nowhere. So it's very important that if you know that this bug had occurred prior and it is again now present over here, so you can trace it back to its root and then fix it again. Well, the categorization of the bugs, we will do it in four ranges basically: low, medium, high, and critical. The low level defects of the bug are very minor, which may affect the product operation, but is not that important. So you'll not pay that much attention to them. Usually, you'll fix it uh, in the end of the each iteration or the product run whenever you are coding or you're programming, or if your one sprint cycle is going by, so you'll not pay that much attention to it, and you'll try to fix it later on. A medium level, a minimum. medium level bug can cause minimal deviation from the product requirement. Let's say that you have an login or a product screen on your smartphone, but the HTML is not working correctly and your application is not that responsive. So it is causing some issues to the user. So they cannot see the complete thing or half of it, but it's not that big of a thing that you'll be stopping all of your work for it. A high level defect, but uh, defects or the bug can affect product's main feature. For example, uh, you could be on a shopping website and you're trying to shop something and you're trying to add this certain product in your cart, but it is just not getting added into it. It is happening with one certain product, but it is not happening with all of the things. So it's a high level bug. It is causing major issues in the in your product, in your software application, but it is not as critical. A critical bug would be the something that you need to fix immediately. For example, uh, there could be a problem in your banking application where the transactions are not getting verified through the banking channel. That is a critical bug and that could be a security risk as well. So you need to fix that on priority, on highest priority. So you can see this categorization low, medium, and high as a bug priority. So however you classify the bug, you will sort it out in the similar fashion. Here's how you'll be. Is a basic template that how we report a bug. It's very similar to how we were doing test cases. We have the date column of first, then defect, application screen name, screenshot, submitted, reproducible, reference, date, software version, severity, and priority. Well, date is basically the date you are testing on it and the bug has been reduced. The defect number is that it is of which number, how many bugs have been reduced up till now, and it is of uh, which serial number. The application screen could be that which screen you are on right now. Screenshots is that you need to attach screenshots of that bugs produced. Otherwise, your developer would say that it never happened. So you attach screenshots as a statement that the certain thing happened. Submitted by it. It will be the tester who did it. Is it reproducible? So there could be some bugs that could not be reproducible or are only reproducible in certain conditions and are not always there but are sometimes there. So that will be a thing that you need to sort out that is it even reproducible or not, or it's something that only occurred to you. Well, again, you'll be putting the reference of that bug, software version. Well, it's very important that uh, if you have studied web development, you would know that HTML and CSS doesn't work similarly on each browser. Well, each browser has its different support of HTML tags and CSS. So you need to put down which software or which software version you were using for that specific testing. Severity is again the impact of the bug on the program. It is not priority, but is kind of interchangeably used sometimes, but it is the impact of the bug that has been caused. If it's major, so the priority would be high. If it's low severity, then the priority of that bug would be low. You put in the defect description at two that what problems did you got, the module name, steps followed. Well, the steps followed would be that how you actually reached the point of that bug and the desired results. Well, the desired results would be that what were you actually trying to do while doing that, and the screenshot that are added into it. So let's see a couple of practical examples Meanwhile, we are here. Before jumping onto Azure DevOps, we'll go by the simple login panel that we were addressing time and time again. So let's do a simple manual testing work. I'll be inputting admin name and the admin password, which are correct. We'll try to log in. Well, we have logged in successfully, and again we'll go back, and now we'll try to do it with an invalid password, invalid username specifically. Now we are trying to log in. Well, the application has blocked us from writing that the validation has failed. That's because we added a invalid password.
Adeep, we cannot see your screen.
Acha,
We can just
wait.
see the
Why? Because I'm not
presentation.
presenting it now. I just take a minute. Sorry guys for the inconvenience. Can you see my screen now?
Yes, we can see it now. Thank you.
Sorry for the inconvenience, guys. Well, this is a open source HR management login page. The login page that we have been addressing all of the time right now. We'll try to do some manual testing on it. We'll first put up some correct username and password and see if the application lets us log in and the developers have done the right job. Well, we could very well log in into the application. That means the developers have done a really good job. Now we'll see that can we log in with a invalid password and a username. So I'm just inputting my name over here and the correct password. Well, the application doesn't let us. Let us write the correct username and some random invalid password and see if the application is still working. Well, it's still not working. Seems like developers have done a really good job. What we were before, let us see one more scenario where we have just made the A that was supposed to be an uppercase A to a lowercase and see that if it still works. Well, it logged in. So basically, we ran by four test cases. In the first test case, we tested that if the applications run by the correct username and the correct password. In the second test case, we ran by with a false password, false username and a correct password. In a third iteration, we made the username correct, but we made up invalid password. In all of these scenarios, are in all of these scenarios, our expected result was the application. In the first scenario, our expected results was that it should pass, it should log in, and it did. In the other two, our expected results were that it shouldn't pass and we shouldn't be able to log in. Well, the application did so, and we couldn't log in. So it again passed our test case number two and test case number three. In the fourth case, where we just changed our username admins A from an uppercase to a lowercase, well, the application's expected result would have been that it shouldn't let us log in, but it actually failed. Well, here, guys, this is a bug. There's a validation error that the developers hasn't put in. The username should always have and validation for the uppercase letters. It should never let us do that because the people could have similar names, similar usernames. If the usernames are not generated or predetermined, it could very well so that people could be logging into each other's profiles. Well, now we'll go into Azure DevOps. And as I told you before, that Azure DevOps is actually a very nice tool and a very technical tool to be. Actually, well, someone's mic is on. Well, Azure DevOps is a very powerful tool for an organizations and software companies to work with, where your team could actually collaborate and work together on some project. So let us see how it actually functions, and we'll not be diving deeper on specifically into its working scenarios and how it actually works, but we'll just be seeing that what functionalities or which functions or features it goes by. So here's we have our main screen and it says test one overview summary. So here's our basic project that a company could be doing by with the test, the name of the project which says test version one, and it only says one member. So basically, if this would have been a software company, there will be more people added onto it. People like project managers, scrum masters, developers, testers, architectures, business people, even maybe clients. So on our first tab over on the left hand side, we can see the summary, the dashboard, a couple of things more. On here we have our worked items, the items that we are working or the processes that we have finished. Here we have our boards that we'll be seeing in just a couple of moments. We have backlogs. Well, what is a backlog now? Backlogs basically means whenever you pursue a project, it doesn't always mean that you'll be pursuing it uh, linearly. That doesn't mean that if you have to make a website, so you will be going step by step, first creating the database, then creating the login, then making that dashboard, then making the shopping list or anything else, whatever the process is. You will break the entire project function by function, requirement by requirement. Once you have done that, you'll group specific requirements together as bundles. Those bundle of requirements of functional functions that need to be developed or built are usually known as backlogs or user stories. It's a very interchangeable terms that could be backlogs or user stories. Where we also see here sprints. So when you are developing a project, now you have made that bundle of requirements or the functions that you are going to be developing in a backlog or a user story. In a sprint is basically a cycle where the whole development team would be working on it. It could be a couple of days, a couple of weeks, or even a quarter. Now you'll be grouping those bundles and user stories or those backlogs. You may be doing a couple of backlog at a time in a sprint, and then you'll be developing and working on to those requirements. Uh, in the sprint cycle, you'll also be developing, but not only developing, but also testing and verifying and all of those stuff that we discussed in SDLC. Well, here is our repos and commits branches. Well, Microsoft owns quite a bit of stuff, and GitHub is one of it. So this is a very interesting thing that basically you can connect the Git over here or in Azure, basically. So this gives a huge amount of flexibility in terms of working from home or working from remotely. So basically, you could be sitting at your home, your other colleagues be sitting in a different country, your other couple of colleagues could be at the office, but you all could collaborate on the work. Well, the pipelines over here is very specifically for the DevOps that we discussed. Not in our scope for today, we will not be seeing that, but you can see the pipelines, environments, releases, library, task groups, deployment groups, and all that work that the DevOps does. This is what we are here for today. Test plans, progress reports, parameters, configurations, run, load test. Load test is a part of performance test where you basically stress test an application to see how much load it could actually get on with. For an example of from a browser, we try to open as many as tabs, open heavy websites which requires heavy server data, and we'll see that how much our browser could survive. Test plans over here, end up with the screen. It says test one, define. There's a chart over here. We could define a new test case. We'll put in the title as we went through that how the test case are written. It need to have a title, the steps that we'll be going by here, can add couple of steps that how you'll be going by. The parameter values, that what values you have predetermined to check the valid or invalid. Discussions, development links that we saw. It could be a GitHub link that ends you up with the same test case or the requirement that you are testing. Related work links or uh, references that you need to put up, and the priorities you can change that. What is the priority of running this test case? We saw low, medium, high, and critical. So you can see the full level and the automation status. So as we are writing the test case, we need to write the test plans. This is basically a test case or a test plan. So you need to write it out. You need to document out the test case. But if it is planned to automated get automation or not is a different discussion. Here's a summary. You will be writing the description that whatever you're going by. Let's suppose you're going by a login screen that I'll I'll be testing the login. Basically, you'll be just writing it straightforwardly. There's no special procedures or parameters in writing the test cases. Associated automation, test case name, test storage type, and that all. Again, putting in links, any links that are to be here, and attaching those screenshots and all of those things that we talked about before. Start the changes for now. And when we'll come here to the board and like let's see that how those backlogs and things work. Well, discuss how the backlogs work. So consider this thing, the to-do thing, is a backlog that needs to be executed. It is in the pipeline. And here's a backlog which says US6, US3. It is what the developers would be working on right now. So here's what the it's being done, and here's what's actually done. So you'll be if based on the scenario, if the scenario the test driven development, so you'll be basically the part of the testing team in from the development side right now. So you'll be like adding a test, deleting, move to iteration or anything, or adding a task, adding more functionality based on whatever the scenario might be with the client or the specific time at that point. Here you are basically seeing what the development team has done and worked upon and not need to get tested for how it fulfills the acceptance criteria and all that. So here you can assign someone. Basically, I'll assign myself to test this. So then basically I'll be going down. So I haven't wrote anything about the requirements for the functions that are being done in this case. So it is actually empty. But in a company, if that would be, it would be containing some description about the functionality that has been implemented. How you'll reach that build the release numbers and all of that. So if I would find some type of a bug in it and I have reported that bug and my project manager has said, okay, now forward it to the development team. I'll be just moving it like this. I'll just be doing this and the development teams will get all their notifications and all of their emails that certain work has been assigned to them. They'll be accepting that and then working on that. Before putting it back to them, I'll be defining that what problems, errors, or bugs that have caused that issue has made me do extra work or put their work that they have done as a bug. Here we have backlogs. Let's see what backlogs are having. Well, here's all our backlogs that we have created. You can see the state that uh, what is ongoing, what is to do, and what is assigned to whom. You can add new backlog from here. This is, you can basically add again new backlogs of work as more work pour in. You can make a new sprint cycle. You can put whatever the name would be, put a start date and an end date of that cycle, put the location of this, if it's the existing iteration or iteration that is coming in planned. So yeah, well, that's all for DevOps for now. And yeah, guys, that is the end of the session, uh, end of whatever we planned for. Also, if you could please stop the recording so we could move on with the QA session and what someone had asked